This is the power supply that failed last time. It's this power supply. There's no burnt mark in the PCB or other parts. The only parts that I've found that have failed or shorted is the switcher. It's this one here. And I already got the replacement part here. I ordered it from AliExpress. I'll be back after I replace the part. This is the part that has failed here. As you can see, it's a shorted. All the leads are shorted. This is the replacement part here. The power supply has already been fixed. We just replaced this one, the primary switcher. One thing to note about the power supply is it does not like cross loading. If we put a small load here on the 12-volt minor rail, it's gonna affect this one. I think this is the negative output. That is just 100 milliampere, just about 1 watt, and the output has risen by about 0.2 volts. With the load of 10 watts on the 12 volts minor rail, the voltage has increased around the 1.1 volt. So there's about 1 volt difference between the negative and positive major rail. So when we're doing the testing, we're just gonna turn this on. So these are no load voltage here. I've recorded our no load voltage here. Now we're going to, I already set it here 2.4 amps there and 2.4 amps there. That's going to pull about 100 watts. We're just gonna turn this on. See, that's about 101 there and 101 there. And the voltage should load is about 42.2. So the voltage regulation is pretty good. There's only about 0.1 volt difference there, and you still have some voltage drop here on the cable here. So I've connected the multimeter there. Oops, need to connect it there. Still going to do this with one hand. Right, I'm measuring the voltage drop on this cable here, on this red cable there. So there's just about 12 millivolt voltage drop there, so that's very minimal. So the power in is about 228 watts. So we have about 202.4 there, just 202 watts divide 228 watts, and this our efficiency. So our efficiency is about 202 watts divide 228. It's about 88% efficient. 88.5, 88, 8.6% efficiency. Now we're going to measure the ripple. This is the ripple here. We're just gonna pause. Going to use the measure function. Measure. This is our ripple here. This is the peak ripple and the minimum. So the maximum ripple peak to peak is 94.4 millivolt. This should be the from peak to peak here. Let's try to measure that. Start. As you can see it there, that's a ripple there, the maximum ripple peak to peak 94.4 millivolt. That is from the peak there and the other peak there. See, as you can see, the oscilloscope already did the measurement for us there. You can see it's the peak to peak 94.4 millivolt maximum ripple. So we're just gonna put it then, ripple 4.4 millivolt. Okay, so this is the result here. Our efficiency is 88.6%, ripple 94.4 millivolt, and this is the difference between the no load and the loaded voltage here. There's only 0.1 volt difference, so the voltage regulation is pretty good. As you can see there, the power supply is running for more than 5 minutes now, so, and it's still delivering stable 202 watts there. see if it's hot.